was GM for SageMaker for a little while too, so you've been in this space, for quite some time. Samira, exciting to have portfolio company representation here on the stage too with 6 Sense. She had a distinguished career over at PayPal and has been in this industry for over 20 years and a lot of hands-on experience and practices. And then Brian, he probably can't share everything that he has been doing, but it stretches from helping Obama on advisory work to being a primer and the federal business. That was a significant portion of the primer business, but super deep bench of people here. One of the things we're going to chat about here today is the importance of data. I think all of us have dealt with data in various forms and shapes, particularly around data analytics and BI and so forth. So we know how painful that is. Now, of course, with large language models, there's another dimension to this, which brings in structured and semi-structured and unstructured data into this format as well. And so we thought we were going to spend some time talking about those practices and early experiences that people have made in that regard. Clearly, managing data in this environment for general applications, becomes super critical. And so having that data ops strategy becomes, a part of the way that you need to think about not only running the applications, but obviously also in the way that you train and tune the applications. And we thought we were going to, work a little bit on that. So maybe with no further ado, I wanted to discuss some of the main challenges that people are facing when it comes to collecting and unstructured data, managing PDFs, images, and emails and whatnot, all those things, and how people can work on that to kind of get some value from it. And so wanted to discuss a little bit around those technologies, and maybe start with you, Brian, on based upon your experience and what you're doing today. You sit very much in the front and middle of that, right?
Yeah, absolutely. It's been an interesting kind of development arc from the ChatGPT moment to today, where ChatGPT came out in November of 2022, and then everyone sort of dusted off the rag paper the month after, and then it was like, okay, well, how do we get data into vector databases, and data loaders were a thing. And across the landscape, there's been such an increased focus on data quality, right? Both for fine tuning as well as for continuously hydrating these architectures. For us, it's gone from our users just thinking about how do we connect to, okay, well, how do we get it into JSON and how do we chunk, to, okay, well, how do we create metadata and structured data around that? How do we get it into a canonical schema? How do we experiment really cheaply without having to redo this at scale? And for the part of the world that we focus on, which is really to the left of fine-tuning or to the left of vector databases. And so the proliferation of choice is one thing, but also the complexity. Just thinking about just the summarization step on summarizing chunks, looking at hierarchical summaries and different structures for doing summarization of those chunks is an unbelievably complex area. And so it's been really interesting to keep track of as folks have been engaging and wanting to feed more and diverse data into these architectures.
Vlad, how are these things working over at Stripe? What do you guys do there, and when it comes to features and embeddings?
Yeah, so for most part, we're not dealing with textual data. So when we're dealing with textual data, it's relatively straightforward in our case, but we have our own proprietary data, which is not text, but it's also sequential in nature. And so we had to be inspired by GenAI and LLMs, and starting to build internally the same capabilities. So when we can generate embeddings, those embeddings are not necessarily textual embeddings, but they're embeddings based on a very sequential text-like, but not text Stripe data. And then we have to deal with how do we represent this, how do we make it accessible to multiple use cases. One of the challenges is you actually want to chain together multiple lookups of the same data, or multiple applications working on the same unstructured data, which means you need to represent that unstructured data in a way that multiple applications can interact with it, but in a consistent way. Mm-hmm. And so a lot of the interesting challenges is around that.
Samira,
About the challenges.
Yeah.
So, just I can give some examples probably.
That would be
more,
super helpful, I think, for people to contextualize it.
Yeah, more deep dive. So if I want to mention some of our challenges, especially regarding our data collection. So it's mainly about the accessibility, quality, and also consistency. Usually unstructured data comes from a different data sources and data storage systems, APIs, endpoints. Each of these sources has their own privacy concern and security protocols that when you wanted to collect it, you should make sure that you follow all of that. And usually it's really hard. You build a standard approach to collect all of this data. Another challenge that we have is regarding to the format of the data and also the shape of the data, basically the quality of the data. For example, we have a product, is a conversational email, so we let our customers to upload their documents about their product and company, and each company has their own way to present themselves. So, but we need only a small set of that information that contain all of that important information, and we should actually look at all of that huge amount of data and chunk data in the way that we finally get that piece that we needed. About the consistency also, we see lots of challenges because, again, we build a RAG framework internally for our internal team. If they have any question from our knowledge base or Confluence pages, they can ask the question about that data. But the fact is each team, the way, the terminology and the way that they are solving the problem, look at the one specific problem is different. And now we don't have a consistent information about one problem. So how we actually are collecting information for a different persona and customize the answer also, this is something that we need to customize our extraction and also data collection.
Makes sense, makes sense. What role does the data labeling and classification play in that environment, and to what extent is that heavily done by humans, or have you started automating some of those things?
Yeah, for sure. When you talk about the classification, basically you need some sort of supervised model. So because of that, label is the most important part of that. Recently, we started to use GenAI to label our data. What we found, we have different use cases. For example, for email intent classification, we use GenAI. We found that we can get the accuracy around 70–80% when we ask GenAI to label the data for us. For some use cases, this is good enough. But if we need to more deep dive, so we can build more customized algorithm. For sure, human always in the loop. We are not reached that point that a human is not in the loop yet. And we randomly select some samples. It depends on the use cases. If the use cases is very sensitive, sometimes, especially at the earliest stage, we go for 100% human review for some of our use cases. The other approach that we found it very useful, usually for the GenAI models, you need the human-generated text to your actually model become better and better. So what we usually try to build some sort of playground or interactive environment for our internal users to go there and, for example, ask a question, or it depends on the application, and then it enable us to capture real human-generated text with their own label.
Makes sense. Brian, how does prompt engineering and prompt tuning come into this part of the workflow?
Yeah. For us, so you got a single document, a single page of a single document. You have some body text at the top and a picture in the middle and a table at the bottom. We'll rip that document apart, that page apart, and we'll send it to specialized pipelines. But an image, for example, you'll want to send it to a multimodal LLM for an image to text description. And so for us, we've been doing a lot of work with our friends at LangChain and elsewhere to start develop methods to put into CI continuous evaluation of the efficacy of different prompt engineering approaches, so that as models are updated or as they're picking things up through in-context learning and other things like that, that you're actually able to track drift or degradation of the efficacy of those prompts. Additionally, for us, we're connecting everywhere. So we'll connect to OpenAI and Anthropic and Together and Octo and Bedrock and lots of different options. And you're going to want different prompts, right, for different image-to-text models or text-to-text models. And so there's just a lot to keep track of behind the scenes in order to ensure the level of performance that your users expect.
And is there some guidelines on accuracy levels, thresholds, where you think this is critical to kind of get to when it comes to?
You know what? Right now, it's difficult because the gold standard is it's so hazy right now. So for us, we spend a lot of time with human data labelers, and generating gold standard label data for object detection tasks, OCR tasks, and traditional NLP tasks, where there's everyone knows how to do that, and we're able to have large gold standard data sets in order to run that against. From a prompt engineering standpoint, it's every month you just hit refresh on archive and there's new approaches, and so it's a moving target.
And Stripe, Vlad?
Yeah, so somewhat similar. I think the challenge is less prompt engineering and more sort of being able to keep up with evolution of the models and being able to always be on a kind of edge of the state of the art without knowing what works, what doesn't. So one thing we're doing is we're trying to constrain a problem space. We stay away from building a very general purpose solutions with LLM. For whenever we use LLMs, we're actually defining the solution space relatively narrowly, so we can define a set of use cases that we can use to benchmark against. And then we continuously and almost automatically continuously benchmark. Then it becomes very easy for us when the new models comes around to evaluate it. Also becomes easy for us to understand when the existing models stop working reliably because the inputs from an outside that we don't control changed in shape, and the prompts that we already developed are actually no longer kind of giving us the sensors. And you can only do that if you have a relatively narrow problem space, because otherwise it's almost impossible to build a good enough benchmarking set. So I think that's been kind of an interesting learning as we started building. Because we started from general purpose, and then we really, really narrowed things down.
Yeah, I think another strategy we see more and more playing relevancy is sort of the usage of synthetic data. How do you augment your training volumes and so forth with synthetic data?
Actually, for me, yeah, of course. So, first of all, we try not to use synthetic data as much as possible. But sometimes for training purposes, because you have a lack of data for some classes, so you have to do it. For sure, every time we actually generated the samples, so we check it with the real data, make sure the distribution and characteristic follow the real data set. We have I can give you some examples. For example, in our product, when we receive the job title of the people, we classify that to the different function and level. But for this model to be able to detect any kind of function across the industries, and include all the functions. So we use GPT to create that training set to make sure that this is included all the possible function that is there. For some use cases we use it, but only for training purposes.
Okay. And how do you think about introducing bias in those?
Yeah, so because of that, we are trying not to use it. So, but in some, we usually try to even do human review, so to make sure that the data is not biased.
A lot of talk about embedding strategies, and I think that's one of the novel arts still in kind of large language models, right? And I don't know how you guys think about that, but what are some pointers or thoughts that maybe the audience here should think about when we talk more about high quality embeddings from various data? And Brian, I don't know if you can touch a little bit on that.
Yeah, I think there's a couple interesting trends going on right now. One of them is fine-tuned embedding models, and so we were just over at the Databricks conference the last couple of days, and there's a lot of that going on. But also there's a couple of years ago, there's a couple embedding models that you might use for everything, right? And there's a proliferation of choice. I think that is going to continue to accelerate. Ourselves, other companies are working on some interesting stuff where you can just do continuously sample new data as it's coming in, try it against different embedding models really cheaply behind the scenes, and then select an embedding model based on a corpus of data and have that be dynamic and changing. Now, how that scales, given how you're indexing it, is a question. And so I think it's an open question on which way that's going to evolve. If you're going to have really highly fine-tuned embedding models tailored to specific use cases, or if you're going to be able to switch around more freely and as vector databases evolve, be able to accommodate different sorts of embeddings.
Yeah. Given the more structural, sequential nature of a lot of your data set, I think you guys are taking a little bit different approach, right, to RAG and embeddings?
Yeah, because our data is by and large non-textual, so we actually end up building our own embeddings model. So we're often using LLMs to kind of bridge into human language or out of human language, but for kind of internal proprietary data, which is by and large is not text, but is sequential in nature, we actually ended up building our own embedding models, and then we kind of built a kind of multi-model applications where we use our own models for things like embeddings, and then use LLMs for things like summarization or providing concise input or generating like a SQL, for instance. Or we use LLMs for embeddings if the input is textual, but then we have a sequence of other models that we build to do a task-specific thing. So it's like we found that it's rarely a single model, and it's always a combination, and often there is a bit of a proprietary model that's either enhanced or combined with large language models.
Got it. Samira, you guys have built a pretty sophisticated RAG framework.
Yeah.
Talk a little bit about that.
Yeah, sure. So as I mentioned, for a RAG framework, there's an inconsistency in our data, even in the format of our data. So first, I think we started to use LangChain, but then we realized because of all of this inconsistency, is not that much accurate. So we built our own customized chunking algorithm. So now we have our own to make sure that we get the good quality actually data. For embedding, we are using a structure from Hugging Face. It's handle the different tasks like classification, clustering, or extraction. So we use it for extraction. It works well and fast. For chunking the data, because it's very important, I want to say that probably is the most critical part of the RAG framework is that how you chunk your data. Some of the things we also learned through the experiment, for example, when we're chunking the data, we still put the topic of that relevant document to the chunk. So this helps us to increase the accuracy of our retrieval very significantly. There are some, experimental. I think everyone in experimental, and as he mentioned, so it depends on the use cases. We try to define the best way to solve that use cases. Still, I think it's hard you have a universal model that can, do all of these things.
Yeah. And what role does, vector databases and things like this do for indexing, and do you need them, or do you guys find situations where there are different approaches that are better, faster, or cheaper?
I would say, definitely for RAG framework, you need a vector database. We use single store. It's fast and good. Also, for loading the data, also they have a good semantic search capabilities. We use that. So far, so good. So.
Yeah, I would say just building on that, it's interesting that really vector databases are the linchpin. So you had everything, like the world was all built on knowledge graphs, at least in the NLP world that I was in at Primer. We had the inference pipelines, we jam everything through, extract triples, index them into a knowledge graph, and then build applications on top of that. And then everything sort of reverted to ingestion preprocessing, vector database, an orchestration framework, and an LLM. And so this RAG-based, vector database anchored architecture. And in the past, couple quarters, we've seen this blend sort of emerge and like this reemergence of knowledge graphs. And so what you touched on with appending topics, right? We're seeing more folks extract like named entities as well as triples, topics, keywords, and sentiment, and then wanting to index that in a knowledge graph in order, still the game is always going to be how do you deliver exactly the right data to the context window and nothing more, right? And so how can you do that as efficiently and cheaply and fast as possible? And things like metadata filtering, nearest neighbor search, and then also having the knowledge graphs to support that are all, we're seeing a lot of activity in that space in order to deliver those results.
What do you guys do for chunking and strategies around that?
So we haven't like really standardized on like a single vector database. So far, we're seeing like different use cases in different ways. It's like, for instance, we have a very large-scale feature store that we had for a while for like traditional models. And so in many cases, we just found that like loading embeddings into the feature store and using it as a feature to feed into kind of existing models that can combine it with the handcrafted features just works. And so like we use that infrastructure. There's a few applications like simply we're able to do it in memory. And so we have like a simple library that allows you to like bootstrap the vectors. And so it's just too varied for us to try to sort of put it into like a single solution yet. So we'll see. Maybe eventually it emerges as a single solution, or maybe it will end up being kind of a variety of different solutions.
Yeah. Obviously, in some of this data that you guys are looking at, there's a lot of redundant information or maybe fluff that isn't so important and could actually be detrimental to the performance of the models and all this. And curious to hear if you guys have done any experimentation with sparse priming and with representations around that or other mechanisms that can help on the RAG data format and the content, or is that like super emerging space? Is that something you guys have looked into?
So I think in our case, it's probably going to be an unsatisfactory answer, but like in our case for proprietary data, that actually turns out to be the hardest problem. Because the LLM community, like over the years, like back to like original transformers, figure out how to do a good representation of textual data to feed into the transformers for text-to-text kind of conversion. But the minute you step away from textual data, the data representation becomes like super hard problem. And so I think like we're still kind of struggling with trying to take the striped data and figure out what the right data representation is so you can effectively train transformers on it.
I'd say on our side, it's still like a text primitive is almost essential to like getting forward momentum on these. And so we're finding like coming back to the embeddings, like multimodal embeddings being very difficult to work with, and things reverting to like a text native in order to try and get some of these POCs or even small scale production deployments going. And so I think it's something to keep track of, but we're not seeing a lot of activity in that space quite yet.
Maybe looking a little bit in the crystal ball, what are some of the advancements in technology that you were hoping can help make your job a little easier on some of these fronts? And also maybe anecdotally, if there's some mistakes that the audience can learn from that you guys have gone through that are easy gotchas to share. Love to hear maybe some few words on that in the few minutes we have left.
So maybe I'll echo Will, that presentation that resonated very much. I think how to build applications with this technology is going to be one of the kind of biggest advancement. Like the pieces are there, and the pieces are going to evolve and become better and more performant and so on. But it seems to change the mental model of how you develop software. And I think figuring out that mental model, that setting into design patterns that like software engineering built over like 40, 50 years, and now we're rethinking them. Like that's probably going to be the biggest unlock once we collectively figure out how to build applications in a new way.
Yeah. Samira?
So if I want to quickly, because we are out of, so I want to say that we have focused a lot on problem-solving skills in the past, and by AI and GenAI providing lots of powerful tools for providing the solution, I think now is the time that we are start to focusing on identifying the problem, right problem, because solution is there. It's easy to get any solution, but the main, I think, challenge right now is identifying the right problem to solve.
Yeah. Super.
Also kind of building on some of Will's points previously, but I think a very unsexy aspect of this is that on the data side, at least where we're living, it's all being driven by folks that like speak in Python and work in vector databases and deal with LLMs, but it's all going to be sustained and scaled probably through data engineering teams that speak in SQL and data lakes and BI applications. And so like culturally, how those come together and how organizations are able to scale the data that they make available to these LLMs, I think is going to be a big challenge as like they want to take all of the data that they're generating, that's human-generated data each day, and make it available to LLMs. And so that's an interesting challenge.